Okay, hello. I just saw you earlier today, but now I am teaching you lesson 5.2, in which we're going to talk about intercepts. Okay, so I made a conscious effort to try to write with a pen that was working better and to write larger. So hopefully that works for you. Over here, there's some glare, but I'll make sure that you know what this says so it can go in your notes. Okay, so first I'm going to just introduce intercepts, and then I am going to do a couple of examples. You don't need to write this, but you will need to write this. And remember, over here in the corner, there are two slides, two images. I want the top of your notes to have the lesson 5.2, understanding intercepts, and those three questions written. That should be the first thing on your notes. And the second thing on your notes should be the recall, where it says recall that a linear function can be written in the form ax plus by equals c. We're going to use that extensively in this lesson, okay? So take a second to write those, and then follow along with what I'm about to share to explain to you what intercepts are. Now, we've talked about intercepts before, so this may be a little bit of review, but we'll speak explicitly about what intercepts are here in this lesson with some formal definitions and really work with them to graph a line. Okay, but first I want to talk about a real-world application. All right? So imagine there are these miners under the ground. Right? So this is an example that comes out of your book at the beginning of the lesson, but I'll explain it here. So these people work underground digging things out of rock, right? And so they have to get deep underground and they have to get in and out easily. So they have an elevator that takes them down to the mine and then takes them back up to the ground surface. So this graph right here shows the height of the altitude, the depth of the miners, the elevation. So the y-axis is the elevation of the miners as they come up an elevator that takes them out of the mine to the ground level. So notice this is our origin. So this is the x-axis and this is the y-axis. Okay? So x is time, right? The horizontal characteristic is time. So along here, time is 0. They have not spent any time in the elevator when we are along here. Okay? Then over time, over 3 minutes actually, they go from, in the book it says this is negative 90. So they are 90 feet below the surface of the ground. Over 3 minutes, the elevator goes from 90 feet below ground to 0 feet or ground level. Okay? So right here, their height above or below the ground is 0 along the x-axis. Here, on the y-axis, the amount of time they've spent in the elevator is 0. Okay? So right here, x is 0. Right here, y, their height above or below the ground is 0. So here they've spent no time in the elevator. Time is 0. Here they are on ground level. Their elevation is 0. Okay? So these right here are intercepts of the graph of the miner's elevation over time. The intercepts of a function are the places where the graph crosses the axes. Okay? So this graph touches the y-axis here, and it touches the x-axis here. So this is called the x-intercept, because it's where the graph intercepts the x-axis. So where the graph and the x-axis cross is called the x-intercept. The y-intercept is where the graph and the y-axis cross. So it's where the graph intercepts the y-axis. Okay? You may know intercept like in football. Somebody intercepts a pass. So the football is going somewhere and then a defender catches it, he intercepts it, they cross at that point. So x-intercept is where the graph crosses the x-axis. Y-intercept is where the graph crosses the y-axis. Okay, so over here, this should be the next thing. After lesson 5.2 with the questions and the recall, then this should be the next thing you write in your notes. Okay? The y-intercept, y-intercept is where the graph crosses the y-axis. And I drew a picture of a vertical axis here to remind you that the y-axis is the vertical one. So the y-intercept is where the graph crosses the y-axis. And it's helpful to remember that at this point, at the y-intercept, the value of x is 0. Okay? So the y-intercept is always in the form of its ordered pair is always in the form 0 blank. 0 and then the place where the graph crosses the y-axis. So the y-intercept is where the graph crosses the y-axis. At this point, x equals 0. Okay? So notice right here, this is the y-intercept. Like I said, the value here is -90 and x equals 0. So the ordered pair for the x-intercept of this particular graph would be 0, -90. The y-intercept is -90. The ordered pair would be 0, -90. Okay? So then, correspondingly, the x-intercept is where the graph crosses the x-axis, the horizontal one. I drew a little picture there to remind you that the x-axis is the horizontal axis. Okay? So the x-intercept is where the graph crosses the x-axis. At this point, y equals 0. Okay? So again, right here, x-intercept, it's up or down none off of the x-axis. It's where the graph crosses the x-axis. So y is 0. Okay, so right here, it was 3, 0. 3 minutes, 0 elevation. 3, 0 would be the ordered pair. So the x-axis, the ordered pair of the x-coordinate, the x-intercept is always blank 0. Because y is always 0. Because I can go anywhere along the x-axis. If I come over here, I can go anywhere along the x-axis, and y will be 0. Okay? So any time that a graph crosses the x-axis, y will be 0. All right? So that is defining the x-intercept and the y-intercept. Again, it's where the graph crosses the respective axis, and the opposite variable is 0 at that intercept. So for the x-intercept, y is 0. For the y-intercept, x is 0. Okay? So let's see how we can use this. All right? Let me erase these things. All right. So, example 1, right? This will be the one we work out together. Let's say we have the function 8x plus 7y equals 28. Okay? 8x plus 7y equals 28. And we want to find the x-intercept and the y-intercept. So remember, to find the x-intercept, right? We just have to find the point where y equals 0. Because when we cross the x-axis, y is going to be 0. It's going to go up or down none along the x-axis. So the x-intercept is when y equals 0. So we just rewrite this, plugging in 0 for y. Okay, so we go 8x plus 7 times 0 equals 28. So this just goes away because 7 times 0 is 0, so it cancels out. So what we're left with is 8x equals 28. Now we divide both sides by 8. We see x equals 28 over 8, which can be reduced to 7 over 2. So the x-intercept is 7 halves. It occurs at the point 7 halves, 0. Okay? That's our point. The x-intercept is 7 halves. The ordered pair that corresponds is 7 halves, 0. Okay? Now, the y-intercept, to find the y-intercept, we need to find the point where x equals 0. Because again, if we're crossing the y-axis, we go left or right, none. X will be 0. Okay, so y-intercept is when x equals 0. So we take the equation, we plug in 0 for x, we have 8 times 0 equals, plus 7y equals 28. All right? So again, 8 times 0 is 0, so that goes away, and we're left with 7y equals 28. Divide both sides by 7, and we get y equals 4. So the y-intercept occurs at y equals 4. So the point would be 0, 4. That's the y-intercept. Okay? So pretty simple to find the x-intercept and y-intercept from an equation. You just begin with the equation and plug in 0 for the opposite variable. So for the x-intercept, I plug in 0 for y and solve for x. To find the y-intercept, I plug in 0 for x and solve for y. Okay? So make sure you have this copied down, and then I want you all to try one on your own. So I want you to try negative 6x minus 8y equals 24. And again, if you get stuck or you're not sure, go back and look at the example we just did, okay, to find the x-intercept and the y-intercept. Those are the two things you want to find. Okay? So do exactly what we did in the last example, but use these numbers and find the x-intercept and the y-intercept. Pause the video now and do that on your paper. Okay? Then I'll continue. Okay, you got it? Fantastic. All right, so now we're going to continue. And one thing I want to point out now that we've done those examples, all right, is notice, and you can write this in your notes, I'll put it over here, okay? Notice when the equation is in the form ax plus by equals c, okay? The x-intercept becomes c over a. Because we plug in 0 for y, this goes away. I'm left with ax equals c. I divide both sides by a, x equals c over a. When it's in this form, it has to be in the form ax plus by equals c. Okay? Similarly, the y-intercept is c over b. Okay? And again, we have to first make sure it's in standard form, ax plus by equals c. But if it is, to find the x-intercept, we just take the value on the right and divide by the coefficient on x. Similarly, we take for the y-intercept, we can take the value on the right side of the equals, the c value, and divide by the coefficient on b. Because I'm going to plug in 0 for x, this goes away. I'm left with by equals c, divide both sides by b, left with y equals c over b. Okay? So we can use that now as a shortcut now that we've walked through exactly how to find it by plugging in the values for x and y. All right? So now we're going to look at how to graph. How to graph using just the intercepts. Some of you have heard me mention before that because a line is a one-dimensional figure, you only need 2 points to figure out where the line is. Another reason this is because of what we talked about in lesson 5.1. The rate of change is always the same in a linear function. So when I go right 1x, I go up the same number of y as when I go right 1x again. So once I have 2 points that I know are on the same line, that rate of change has been established. So I can just make a line through those 2 points and I'll know that it's the correct line. So in order to graph a line on the Cartesian plane, I only need 2 points that I know are on the line. So once I have my x-intercept and my y-intercept, I have 2 points. So I can use just the x-intercept and y-intercept to graph the line. Okay, so we're going to do that now with this example. Okay. 1/2 y equals 3 minus 3/4 x. Okay? Now, an alarm should be going off in your head, ding, 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 ding. That is not in standard form. So let's go ahead and put it in standard form. Okay? All I have to do is get this 3/4 x over to the left. Okay? Then I'll have an x term, a y term, and a c. All right? So that's going to be 3/4 x. I add 3/4 x to both sides, so I add it over here to cancel out. It's left over here. 3/4 x plus 1/2 y equals 3. Okay? So now I have it in ax plus by equals c form. All right? So my x-intercept is going to be 3 divided by 3/4, all right, which is 3 times 4/3 equals 12/3 equals 4. So my x-intercept is 4. So 4, 0. 1, 2, 3, 4, 0. Okay? My y-intercept, I'm going to plug in 0 for x. So I have 1/2 y equals 3. It's 3 divided by 1/2, which is 3 times 2 over 1 equals 6. So the y-intercept is 6. Okay? So I go left and right 0, up 1, 2, 3, 4, 5, 6. I now have 2 points. I can connect them. And I have my line. Okay? So once you plot your 2 points, you can connect them with a straight edge, add your arrowheads, and you've graphed the line. All right, so now what I want you to do is pause the video and do that same thing with 18y equals 12x plus 108. 18y equals 12x plus 108. All right, so do that, find the x-intercept and the y-intercept, and then graph the line on graph paper. Bring all of that in on Wednesday, and I'll answer any questions you have, and we'll do some exercises together in class. All right? Happy mathing. Enjoy your time.